Hello again, Math 10Cs. In today's lesson, we are going to look at calculating the slope of a line segment again. Although this time we're going to do it just by using the coordinates for a couple of points that are on the line segment, as opposed to in the previous lesson where we actually needed to view the line segment on a graph and then draw a slope triangle and calculate slope through rise over run. Now, before we jump into the lesson, we'll complete these quick little review phrases here. So let's pull out a pen. Okay, so let's complete the following statements. So slope is a measure of the steepness of a line. Slope is a ratio of the vertical change. So the vertical change in your height is what we call the rise, over the horizontal change in length, which is what we call the run. The slope is equal to rise over run. A line segment that rises from left to right. So if your line segment goes up, we say it has a positive slope. And if your line segment goes down from left to right, then we say it has a negative slope. A horizontal line segment has a slope of, well, if we draw a horizontal line segment like this, horizontal line segment doesn't have any rise to it. The change in height value or the rise would be 0. So if you calculated slope as rise over run, you'd go 0 divided by some run number, in which case you would have no slope. So a line segment with no slope is kind of like you have just like flat ground. A vertical line segment, on the other hand, has no run. There's no horizontal distance to this, but it has all vertical distance. So we can say a vertical line segment actually has an undefined slope, because what you'd be doing in the slope equation is you'd be dividing by a run of 0, and dividing a number by 0 gives you undefined. Essentially what that means is the steepness is infinite. It's like scaling a wall vertically would be like scaling a wall that has a slope that's like infinitely large. And the slope of all line segments on a line are, which just basically means this. If you have like a line like this, and let's say I broke this line into 2 line segments, like a red one here. You broke this into a green one. If both these line segments, the red and the green line, fall in the same line segment, then they would have the exact same slope. And that's why you're allowed to, when you calculate slope with a slope triangle, you can, it doesn't really matter where you draw the slope triangle. As long as it's on the same line segment, you must get the same slope. Okay, now what we're going to do is we're going to use our rise over run formula, and we're going to utilize that to derive an actual mathematical equation that we can use to calculate the slope without actually having to look at this visually. So part A says calculate the slope of line segment AB using slope equals rise over run. Okay, so let's first of all let's draw the slope triangle. So my slope triangle would start at this endpoint and go across, and then it would go vertically upward. So I would have a run value that's equal to 1, 2, 3, 4, 5, 6. So we go 6 units across. I'd have a rise value that's 1, 2, 3. Okay, so if I actually wanted to calculate the slope here, the slope, which is rise over run, would be equal to 3 over 6. And the fraction 3 over 6 reduces to 1/2 if you divide both the numerator and denominator of the fraction by 3. B says list the coordinates of the endpoints of that line segment. Okay, so point A, which is at the end here, it has an x coordinate of positive 1, and it'd have a y coordinate that's 1, 2, or 5, 6, 7, 8. So it'd have coordinates of 1, 8. Point B, which is at the very top of the line segment, would have an x coordinate that would be positive 7. And they would have a y coordinate if we go across that is positive 11. So 7, 11. Now C says, how can the rise of the line segment AB be used to determined using the values for YB and YA? Okay, so just to clarify what YB and YA stand for. So I'm just going to go to this point. So this is point A. This point would have coordinates of XA, comma, YA. Okay, this is the X coordinate of point A. This is the Y coordinate of point A. And for point B, this would have coordinates of XB and coordinates of YB. Okay, so XB is the X coordinate of point B, YB is the Y coordinate of point B. Now what I want to do is I want to use the two Y coordinates, so YA and YB, to relate them to an equation that would allow me to calculate what the rise of the equation is. Okay, so let's think about this. So YB is 11, YA is 8. What could I do to those two numbers that would give me the rise? Well, you could subtract them. If you went YB minus YA, that would be equal to the rise on the slope triangle. We can confirm that. YB is 11, YA is 8. 11 minus 8 would be 3. Okay, so I could take the two y coordinates and subtract them to determine what the value of the rise would be. Okay, let's go down here now. It says now we want to do the same thing with the x coordinates. So what could I do to the x coordinates to figure out what the value of the run is? Okay, so the value of the run, if you look at the triangle up here, is 6. So what could I do to the two x coordinates, xb and xa, that would allow me to calculate the run? Well, once again, you just subtract them. So xb subtract xa would be equal to the run. And we can confirm that. The x coordinate of point B is 7. The x coordinate of point A is 1. 7 minus 1 would be equal to the run value of 6. So that does work. Okay, now it says use the results from C and D to basically create a formula that can be used to calculate the slope of the line segment, AB, using only its endpoints. Okay, so we could write it like this. We could say slope is equal to rise over run. Again, that's how we'd normally calculate it off of like a graph. But another way to calculate it is we could also calculate the slope by what's the rise equal to in terms of the endpoints? The rise would be YB subtract YA. And what's the run equal to? Well, the run would just be XB minus XA. So the power of this equation, so I'll highlight this one, is that we could actually calculate the slope of a line segment without even looking at the graph. If we just had the coordinates of 2 points in the line segment, we could plug it into this equation to determine what the slope of the line segment is going to be. Okay, so F says calculate the slope of line segment AB using the formula in E. Well, we've kind of already done that, but I'll just show it again. So we know that slope is equal to YB subtract YA over XB subtract XA. Let's plug the numbers in here. Okay, so YB is the Y coordinate of point B. Now, generally when I plug numbers, I'm going to put them in brackets. This is going to become more of a big deal in the moment we start to deal with negative numbers. So YB is 11, YA is 8. Divide this by XB, which is 7, then subtract XA, which is 1. So 11 minus 8 would be 3, and then 7 minus 1 would be 6. And then once again, if you take that and just divide the top and bottom by 3, you'd get the slope is equal to 1/2. Okay, so whether I do it from a slope triangle on the graph or whether I do using the endpoints, I can actually calculate the slope of the line segment. Okay, G says calculate the slope of the line segment CD and EF using the method illustrated in A, and then verify using the formula from E. Okay, so we're going to do it both ways. We'll do the slope triangle, and then we'll use the actual formula to calculate it. Okay, so let's go to this one, CD. So I'll draw my slope triangle. So I'm going to go down, and I'm going to go across. Let's label this. So the run of this slope triangle would be 1, 2, 3, 4 units across. And the rise of this slope triangle would be equal to, well, from left to right, you go down. So your rise would be a negative number because you're dropping down, and it drops down by 3 units. So if I want to calculate the slope then, so the slope of this line segment would be slope equals rise over run. And this would be equal to -3 over 4. Yeah, I cannot reduce that fraction. Now, the other method would be use the coordinates of the endpoints and then the equation. So first of all, we need to write down what the coordinates of point C and point D would be. So let's do it over here. So point C, let's see if I can get it on the screen there. Yeah, just barely. Okay, point C would have an x coordinate of 2 and a y coordinate of 5. So we'd say 2, 5. And then point D would have coordinates of, point D would have an x coordinate of 6 and a y coordinate of 2. So it would be 6, 2. Okay, so I'm going to write here the slope of line segment CD would be equal to, now I can change the subscripts on the y values. So for this calculation, we're not using point B and point A, we're going to use point D and we're going to use point C. Okay, so we're going from C to D, so I'm going to write down YD, subtract YC, divide this by XD minus XC. By the way, it doesn't matter which order you do this in. You can go D minus C or you can go C minus D. You're going to get the same slope. I'll illustrate this in an example on the next page. Okay, so YD, the y coordinate of point D is 2. The y coordinate of point C is 5. The x coordinate of point D is 6. And then the x coordinate of point C is 2. So if I calculate this, 2 minus 5 is -3. And then 6 minus 2 is going to be 4. So if you just draw the comparison here, so if I calculate the slope using the equation with the endpoints as like the coordinates, you get -3 over 4. And that's the same thing as if I calculate it from the slope triangle using the equation rise over run. Okay, let's go to this last one now. So for the last one, let's draw our slope triangle, line segment EF. So you can go to the right, then you can go all the way up. Okay, so this guy would have a run that's equal to 1, 2, 3. And it would have a rise that's equal to, now you go up from left to right, so the rise would be positive, and you go up by 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 units up. Okay, now to calculate the slope, so the slope would be equal to rise over run, which would be equal to, the rise is 9, the run is 3, and then I would get a slope value of 9 divided by 3, divides evenly, you get it's equal to 3. Now, I also want to use the endpoints in the equation to see if I can get that same slope. So we need to write down the coordinates of point E and F. So let's go back up. So E would have coordinates of, I believe it has a x coordinate of 9 and a y coordinate of 3. So we could write down 9, 3. And then the F coordinate has an x value of 12 and a y value is the same number, also 12. So 12, 12. Okay, so we're going to calculate the slope of line segment EF. Let's write a little subscript here to identify that. And this would be equal to, and again, I can change the letters that are on the subscripts to match up what I'm doing here. So we're going from E to F, so I'm going to say YF minus YE divided by XF minus XE. Let's plug these numbers in. So the Y coordinate of, whoops, this should be a 12 here, not a 2. The Y was 12, 12. So 12, 12. So you'd have 12, subtract, the Y coordinate of point E is a 3, and then divide by the X coordinate of point F, which is 12, minus the X coordinate of point E, which is a 9, and this would give you 12 minus 3 is 9, and then 12 minus 9 is 3, and then this would give you 9 divided by 3 is 3. And again, we can confirm we got the same thing. So using the slope equation for the endpoints, I got a slope of 3. And then up here, I used the rise over run by drawing a slope triangle. I also got a slope that's equal to 3. Okay, so both methods work. It's just this method down here is more useful if like you're just given the coordinates and you don't want to plot the points onto the graph. So it's a bit time consuming now to actually plot the points in the graph and then draw the line segment and do a slope triangle. So you can actually use the equation to skip that step if you know what the endpoints are. Okay, so let's go to the next page. Okay, so it says, in mathematics, we like to use the letter M to represent the slope of a line segment. Now in science, typically we don't do that just because in science, in physics or in chemistry, we like to use M to represent the mass of some kind of object or substance. But for math, we'll use M to represent the slope. Okay, so M is a variable that's used to represent what the slope is. Okay, so if you have a graph of linear relation and it passes through 2 points, point P and point Q. So point P has coordinates of x1, y1, Q has coordinates of x2, y2. You can calculate the slope by taking the numerator would have y2 minus y1 or x2 minus x1. If you want to write it in terms of the actual coordinates themselves, you can change the subscripts. So I could change the subscript 2 to Q because point 2 is Q here. You could change the subscript on 1 to P because point 1 is point P. The important things to recognize is there's a difference between your y coordinates and x coordinates, and also the difference in y is on the top and the difference in x is on the bottom. That's because the difference in y is your rise and the difference in x is the run. And again, slope is rise divided by run. Okay, so let's look at an example here. Okay, so all we have is the 2 endpoints, and we're simply just going to plug the endpoints into the equation to calculate the slope. We don't need to draw the line and do a slope triangle. So the y-coordinate of point H would be -2. And again, this is where it's important to like plug these numbers in brackets. Whenever we do any kind of substitution in math or science, like it's always good practice to like sub stuff in brackets. Okay, minus yg. Yg would be the y-coordinate of point G, which is 8. Divide by xh, so that's the x-coordinate of point H, which is a 7. Subtract the x-coordinate of point G, which is a -3. And then you get -2 minus 8 would be -10. And then 7 minus -3. Well, you're going to add, subtracting a negative is the same thing as adding a positive. So it'd be 7 plus +3. So this would be 10. -10 divides evenly into 10. That would give you a slope value that's -1. Now, this example gives you a couple of endpoints. So it tells you that point E has coordinates of 15, 8, and point F has coordinates of -10, 6. And what it does here is it shows a bunch of different students' work for calculating the slope. But it turns out every single one of these students has done the slope calculation incorrectly. So what we want to do here is we want to identify like what mistake did they actually make. Okay, now I think the easiest way to do that is to do a correct slope calculation first. So that's the first thing I'm going to do. So we want to calculate the slope from E to F. Okay, so this would be equal to YF minus YE divided by XF minus XE. So let's go up and see what the coordinates are. Okay, so the y coordinate of point F is 6. Subtract. The y coordinate of point E is 8. So you'd have 6 subtract 8. Divide by the x coordinate of point F is -5. Or sorry, not -5, -10. And the x coordinate of point E is 15. So let's go ahead and calculate that. 6 minus 8 would be -2. And then -10 minus 15, you're subtracting a positive number. So that just be -10 minus 15 to give you -25. Now you can't reduce this fraction, okay? Nothing divides evenly into 2 and 25 except for 1, but the two negative signs actually would just cancel each other off. Negative divided by negative is a positive. So this would give you a positive slope. So this would give you 2 over 25. Okay, now let's try to figure out what errors the students made in their work. Okay, so we have Eleanor first. So they have -10 minus 15 over 6 minus 8. So their issue here is they've done the subtraction of the x coordinates on the top and the y coordinates on the bottom. So her problem here is that she needs to switch these. Again, the top of that equation represents the rise, which is the change in the coordinates of the y values. And then the denominator of the equation represents the run, which is the change in value of the x coordinates. So that's her problem. Bonnie has 6 minus 8 and then 15 minus -10. Well, the numerator is correct. 6 minus 8 is the same thing I had here. And then the denominator is what's incorrect. So what they should actually have is it should be -10 subtract 15. So they just mixed up the order in which they wrote down the subtraction of the y coordinates. So this should be switched. Now, finally, we have Carl. Okay, now I want to point this out. So you might be asking me, like, how do you know that you go F minus E instead of E minus F? It doesn't matter. Okay, you can actually do either or. So let me show you what happens if I go the other way around. So if I go MEF is equal to, so let's switch it. So we'll go E minus F instead of F minus E. So this would be YE minus YF divided by xe minus xf. Now, I'm going to do this correctly. So ye, the y-coordinate of point E is 8. Subtract, the y-coordinate of point F is 6. The x-coordinate of point E is 18. There's not 18, 15. Subtract, and then the x-coordinate of point F is negative 10. Okay, so if I do this calculation, 8 minus 6 is positive 2. 15 minus negative 10 would be 15 plus positive 10. Sorry, 15, yeah, plus positive 10, which would be 25. So it doesn't matter which order you do it in. You can go F minus E, E minus F, 2 minus 1, 1 minus 2 for the subscripts. You still get the same slope. Okay, so let's look at the error Carl made. So he did 8 minus 6 in the numerator. That's no problem, okay? That's the same thing I had down here. Now, what his error is that he did not sub in the correct value of this x-coordinate, because what he should have done is gone 15 subtract negative 10, and all he did here is he plugged in positive 10. And if that was plugged in correctly, then you would actually get the correct slope. Okay, so all 3 students made a mistake. Okay, let's go to the final page. Sorry, just going to erase all this junk here. Just somebody forgot to erase before saving the notebook files. Okay, so we're just going to talk about what it means for points to be collinear. Okay, so as 2 lines in a plane can either be at an angle. So you have line segment AB and then BC. And then there'll be some kind of angle between like these 2 different line segments. I don't know what the angle is here. It looks like it's an obtuse angle, so it's bigger than 90 degrees. You can have a couple of line segments that are, it says parallel and distinct. So parallel and distinct means that they're parallel. So parallel just means that the distance between the line segments is always identical, and the line segments never get closer to each other or further away from each other. The symbol we use to represent like line segments that are parallel is you put these little tiny like arrows on each line segment. So like 1 arrow on one line segment, 1 arrow on another tells you they're parallel. Or you could have like 2 arrows on one line segment, 2 arrows on another one, tells you that they're parallel. Okay, parallel and distinct because the 2 line segments aren't part of the same line. Now the third case is you could actually have 2 line segments. You have line segment PQ and line segment QR. Now, these line segments form a single line. And it turns out if you have points that are part of the same line, we can say those points are collinear. So P, Q, and R are collinear because they all fall on the exact same line. Now, it says if 3 points are collinear, then the slope of line segment PQ is a slope of line segment QR is a slope of line segment PR. Now we already know that because we already identified if you have a bunch of line segments that are on the exact same line, they have the exact same slope. Like for example, if you calculated the slope of like line segment PQ, and if you calculate the line segment of QR, yeah, the slope triangles look different, but the ratio of the rise to the run would be identical. So you get the exact same slope. And the slope of PQ and QR would actually be the same as the slope of line segment P to R. So if you did a really big slope triangle, went all the way across here, and then you went all the way up, you get the exact same slope. Okay, so it doesn't matter which line segment you look at, P to Q, Q to R, P to R, all those points are said to be collinear because they fall on the same line. And if they're collinear, it means the slope of every single line segment is going to be identical. Okay, so let's try to apply this in an example now. Sorry, I really should have made sure to erase this stuff before opening the document, but that's okay. Okay, so it says consider points A, which is 5, -3. You have C, which is A, which is 5, -3. B is 2, 6. And then you have C, which is -7, 33. Okay, so again, sorry, I just got to erase this. A says prove that points A, B, and C are all collinear. Okay, so here's how you would need to do this. I would need to calculate what is the slope of line segment AB, the slope of line segment BC, the slope of line segment AC, and if they're all identical, then I can conclude that they fall in the exact same line. If they all have the same slopes, then that means they're all part of the exact same line. Okay, so let's do these calculations. Okay, so let's start off with calculating the slope of AB. So the slope of AB, write down YB minus YA over XB, subtract XA. Again, you can go B minus A or you can go A minus B. The only thing that matters is that if you go B minus A on the top, it has to be B minus A on the bottom. Like you can't go B minus A on the top and then A minus B on the bottom. So it can either be B minus A on the top and bottom or A minus B on the top and bottom. Either is going to give you the same slope. Okay, so let's plug these numbers in. So YB be the y coordinate of point B, which is +6. And then we're going to subtract the y coordinate of point A, which is -3. And then we're going to look at the x coordinate of point B, which is 2. And then subtract the x coordinate of point A, which is 5. So this would give you 6 minus -3, be adding a positive, so it would turn into 9. And then 2 minus 5 would be -3. And then 9 divided by -3 would be -3. You'll do the same thing for line segment B to C. So a line segment BC would be equal to YC minus YB divided by XC minus XB. Let's plug those numbers in. Y coordinate of point C is 33. The y coordinate of point B is 6. Divide by the x coordinate of point C is -7. Subtract the x coordinate of point B is 2. All right, so 33 minus 6 would be 27. And then -7 minus 2 would be -9. 27 divided by -9 would be -3. Okay, and then the last one, so we got to do every combination here. So we did the slope between A and B, the slope between B and C, and now we want to also calculate the slope between A and C. So I'll say MAC would be equal to YC minus YA divided by XC minus XA. So this would be equal to the y coordinate of point C is 33. Subtract the y coordinate of point A is 5. Divide by the x coordinate of point C is -7. Subtract the x coordinate of point A, which is, oh, I did that incorrectly. My bad. Let's fix it at the top here. Sorry, the y coordinate of point A would be the y coordinate of point A is -3. Let's get -3 here. The x coordinate of point A would be 5. Okay, so this is going to give me 33 minus negative 3 would be adding a positive, so that would be positive 36. And then negative 7 minus 5 would be negative 12. And then 36 divided by negative 12 would just be negative 3. So then what I could say here is I could say since MAB is equal to MBC is equal to MAC points A, B, and C are collinear. Okay, so the idea right here is since they all have the exact, every line segment that forms this line has the same slope, they all must be collinear. They form like the exact same line. Now B says find the value of y if the point D also lies on this line segment. Okay, so if point D lies on this line segment, then it must have the same slope as the line segment. So what we're doing is we're adding an extra little line segment to this. So right here, I think our slope is like negative 3. So if I kind of sketch that, a slope of negative 3. So maybe like you've got like point, I don't know where the points are here. You got A, maybe like B here, and you got C. And it's saying we got like a point D now, and we're trying to check to see if it actually falls on the same line. Okay, so what I'm going to look for in this is I'm going to calculate the slope from A to point D. Okay, now, if I calculate the slope from point A to this new point, point D, and it has the same slope as these guys, then it means it must fall in the same line. So I'll just check to see what actually happens with the slope here. Now, it actually does tell me it does lie on it, but let's just fill the numbers into the equation here. So we'd say MAD is YD minus YA divided by XD minus XA. Okay, now, if D is collinear with A, B, and C, then the slope from A to D must be the same as all these other slopes here. So you can take your pick in terms of what slope you want to relate it to. So I can say it's equal to the slope of A to B, which is equal to negative 3. Okay, now what I'm going to do is I'm going to plug in a bunch of different numbers here. So in this example, I actually know what the value of the slope is. So in the place of AD, I'm going to plug in negative 3. So this would be negative 3 would be equal to, okay, what's the y coordinate of point D? Well, it's an unknown value. It just tells me it's equal to y. So we'll just leave it as y for now. Subtract the y coordinate of point A is negative 3. So you have negative 3 here. And then divide by the x coordinate of point D, gives it to me, it's negative 4. And then I'm going to subtract the x coordinate of point A, which is a 5. Okay, let's clean this up a little bit. So we'd have negative 3 would be equal to y minus negative 3 would be adding a positive, so that'd be y plus 3. And then we're going to divide this by negative 4 minus 5 would be negative 9. Now, what I want to do is I need to isolate for y. To isolate for y, I first of all need to get this expression by itself. I need to get the y plus 3 by itself. So to do that, I got to get rid of this negative 9. Now, the way to get rid of that -9 is you can use a trick called cross multiplication. We did this a little bit in the unit on trigonometry when we were rearranging those trig ratios. So to get this guy out of the bottom, I can bring it onto the top on the side across. So what this would then look like is you would then have, so you bring the -9 up to the top here, we're going to multiply those numbers together. So that'd be -3 multiplied by -9. If you put two brackets side by side, means multiplication. And that would be equal to y plus 3. Now, -3 times -9 would be positive 27. So the positive 27 is equal to y plus 3. To get the y by itself, just subtract 3 from both sides of the equation. Subtract 3. And that would leave you with a y value of 27 minus 3 would be equal to 24. So if I want point D to be collinear with these points, which means it needs to have the exact same slope, the y-coordinate would have to be 24 to give you that slope. That's really what I did here. Okay, so which questions can you do? Okay, so on this assignment, you can do numbers 1 through 7. But I'm going to get you to omit a couple of questions because we skipped over those sections on calculating distance between points and also calculating the midpoint. So you can omit 6b and you can omit 4, B, and C. And I will talk to you in the next lesson.